So we have 40 questions again. So all 40 should be answered. Each one should be like there is no negative marking here. So you can just answer. If you know properly, you can answer it correct answer. Even if you don't know, so you have to tick any of the 4 options. Okay. So but this like guessing the answer should be the least priority. At the last minute, if you do not know the answer, so what is the exact answer, then you can choose for the one which is more closest to the or more closest or most expected from your side. Okay, so that you can choose when it is in the least possible case only. So try to solve the questions and try to get the exact answer, therefore you can able to score maximum marks. Okay, so let's start our session with the first question here. In the visible spectrum, the violet light has highest frequency and red light has lowest frequency. Okay, so is it correct or not, tell me. So in the visible spectrum, okay, so we have VIBGR colors in the visible spectrum. So VIBGR, so V indicates in the first VIBGR, V indicates what, violet, and at the end R indicates, in VIBGR's R indicate, VIBGR R indicates red. So violet will be having more frequency, what I am saying, more frequency or more energy and low lambda for V. Okay, VIBGR, in VIBGR V will be indicating violet, it will be having maximum frequency or highest frequency, okay, and low lambda, you can remember this. And in the R, here R indicates what, so R indicates red color, so this red will be having low energy or low frequency, and low frequency I am writing, and high lambda, high wavelength I am writing. So what they are saying, so high frequency, lowest frequency for red, yes, this is correct only. So low frequency I told you, yes, that is correct. Okay, the next statement, let me check everything is visible, yes. Okay, so when white light is passed through a prism, violet light is deviated most and red light is deviated least. Yes, this is also correct. Okay, so whenever we are sending white light through this prism, so now splitting of this white light takes place into the colors like VIBGR colors. Okay, so now the one which is having maximum frequency, that is what, violet, maximum frequency and minimum wavelength, so that will deviate with maximum angle, so it will deviates more, and red will be having low deviation. Okay, so means this is violet and this is red, because why it is happening like that, so violet will be having maximum frequency and minimum wavelength. Okay, so therefore violet will be having more speed now, so it will be coming up with maximum deviation. So this is also correct. Okay, so which is violet deviated most and red deviated less, that is also correct statement. Hydrogen atom in gas phase exhibits line spectrum, that is also correct. So 1, 2, 3 are correct. Do we have any options like 1, 2, 3? Yes, option 4 is 1, 2, 3, you can choose it. Okay, so this is the correct one. This is the answer. Okay, let's move further. 122, the emission spectrum of hydrogen contains few lines. The energy of the lines, energy of one of the lines is this much. Okay, so what we can see, emission spectrum of hydrogen atom contains few lines. Okay, the energy of one of the lines is this much. Okay, the N2 minus N2 and N1 belongs to the N2 and N1 belongs to this line respectively are. So what are the numbers of this N1, N2 they are asking, simple. So what we can see, so we have delta E, energy difference equals to, we have formula like this, like RH Z square like this, 1 by N1 square, this one is there now, so I will be writing it in terms of 2 joules. So why, because they mentioned everything in the joules now, so you have to take in joules. So I am taking 2.18 into 10 power minus 18 joules, 1 by N1 square minus 1 by N2 square. Okay, so this is a formula you can use here. So here Z is how much, hydrogen atom now, so Z square will be 1 only, so we are neglecting that. Okay, so joules. Okay, so now what happens here, so what is the energy difference they mentioned, 0.4578 into 10 power minus 18 joules they mentioned. Okay, this is 2.18 into 10 power minus 18. okay, joules. Okay, so 1 by n1 square, 1 by n1 square minus 1 by n2 square I am writing. Okay, so after this, so units are getting cancelled here, and then next 10 power minus 18, 10 power minus 18 also cancelled. Okay, and if you do this, if you simplify this, so we will be getting, this is 2.1, no? So this will be 0.21, okay, nearest value, okay, which is equals to 1 by n1 square minus 1 by n2 square I am writing. Okay, this is the value we got. Okay, so now, so this 21, 0.21 I am writing 21 by 100. Okay, so 21 by 100 I have written here. So now, by placing this 1 by n1 square, n2 square, by substituting this value, you will be getting this ratio. Let us check once. Okay, so here n1 square, let us see, 1 by n1, n1 is 2 square, 2 square 4 I am taking here, and 1 by n2, n2 is 5, 5 square it is 25. Okay, we can take like this. Okay, so now LCM of this 25 and 4 will be how much? 100. Okay, here I am writing 100. Okay, so in 4 table we can write here into 25. Okay, and here it is 4, so it is into 4, so it means 4. So we got 100 by 21. That's it now. So this is what we got. So first option is verified and it is giving perfect value as this much. So 21 by 100 I can write 0.21 now. So it is correct only. So which option is correct? So first option is perfectly fitting into this. So this is what option verification method. Okay, you can use like this. Okay, I hope it is clear, there is no confusion. Okay, so what I taken? I have taken general formula delta equals to 2.18 into 10 power minus 18 joule into 1 by n1 square in minus 1 by n2 square. That's it. So n1 is lower value, n2 is higher value. Okay, so now this is the energy given. So ratio you take, ratio we got 0.21, I can write 21 by 100 right now. So now this 1 by n1 square minus 1 by n2 square will be this is the value. So in order to get this value, you can substitute these 4 options into this n1 and n2. You will get one of that option will be satisfying this condition, this value. So that will be your final answer. So first one is satisfying this, that will be your answer. You can check for other options also. So you won't get for other option, only one is correct. Okay. Now isoelectronic species, this is easy question and general question. So isoelectronic species means what? So same number of electrons should be there, same number of electrons. So here how many electrons are there? Magnesium plus 12 minus 2, that will be 10. Aluminum 13 minus 3. So Al plus 3 means aluminum atomic number is 13. So plus 3 charge, it means you need to remove 3 electrons. So 10 electrons are there. So 10, 10, and here F minus 9 plus 1, 10. So this is isoelectronic. Here also this is also 10, 10 electron. This is also isoelectronic. And here potassium plus 18 electrons. This is 18 electrons. And when it comes to this, scandium 21 minus 3, this is also 18 electron. Okay, so it is also perfect. Okay, then we can move for this option. See, this is 25 minus 2, so it is not having isoelectronic species, so you can remove this. Why? Because atomic number is 21, 25 minus 2, so 23. Iron 26, okay, 26 minus 3, 26 minus 3, so 26 minus 3, 23, here 25 minus 2, 23, okay, and this is scandium, titanium, vanadium. How much it is? 23, scandium 21, vanadium 22, scandium, titanium 23, this is 23 and minus 3. How many? 20 electrons are there, so this is not the correct one. So first 3 are isoelectronic. I hope it is clear how we are solving. 1, 2, 3 are the perfect answers for this. So let's see here. 1, 2, 3 it is there in second option, so you can choose that. Okay, so you can go with second option here. Okay, I hope it is clear. Then next, let us do one more question here. Which are the following set are correctly matched? So tell me which is correctly matched here. So atomic radius, is it correct or not? So from left to right, what happens in periodic table? From left to right, it means from S black to P black, what happens? So atomic radius decreases. It means S black will be having in a period, S black elements will be having more ion radius than this P block. So it means lithium having more than beryllium, right? It is correct only. Next, ionization energy, alkali metals will be having least, yes, least, and silicon having more. What is the group 2 period, third period elements we have sodium, magnesium, aluminium, silicon, next phosphorus and chlorine, like this. So if we take this, chlorine will be having maximum, okay, and the next what about sulfur and chlorine, okay. So here in sulfur and chlorine, what we can say, halogens will be having maximum, okay. After this, so phosphorus half fill configuration, it will be having more than the sulfur, and like this sulfur will be then, and the next magnesium will be having more because of its 3s2 electronic configuration, it is having 3s2 3p1. We can easily remove this one electron from here, okay, but from here we cannot remove electron because it is in the s orbital, which is having more penetrating power, okay, than this p. Therefore magnesium require more energy than aluminum, therefore ionization energy of magnesium is more than aluminum. So this is also correct, so this is also correct, everything is correct, okay. So I hope it is clear. Second statement also clear, second also clear, first one also right. Electronegativity, so which is more electronegative? Fluorine is more electronegative than oxygen, then nitrogen, then next carbon, okay. This is also correct. So 1, 2, 3, all three statements are correct for this question, okay. So then next let us move further. HgCl2, so what is the bond angle here? So HgCl2 having sp hybridization. Sp hybridization means 180 degrees angle linear, right. So ammonia is having pyramidal geometry 107, so water is having bent shape which is having 104.5. These are basic things now, so this is a very basic question. So 180 is greater than 107 greater than 104.5, so option 4 is correct only, okay. Let's move further. Again MOT, will you try to solve this question? So just take some time and try to solve this very basic, very basic question. Even 11th class student can easily solve from chemical bonding, molecular orbital theory. So without knowing this concept, you cannot go to your exam because that is very highly important topic. So just give a try. So I will explain you by taking some water. Okay, anyone in online? Okay, let's discuss. The electronic configuration of N2 in terms of molecular orbital theory, okay. So in terms of MOT, molecular orbital theory, so we can write sigma 1s2, sigma star 1s2, or else we can write kk, it represents the first energy level orbitals, okay. Then next sigma 2s2, sigma star 2s2, done, okay. 14 electrons are there. So up to here 8 electrons are over. After this we should fill in the pi orbital, pi 2px equals to pi 2py, which are degenerate orbitals. After filling this, we have to fill in this sigma 2px. It means this is this side and this is first, okay. I mean before this should be there. So pi comes first, then next sigma 2px, okay. So but order is given in the reverse manner, so therefore this filling is incorrect, okay. First one is incorrect. According to the molecular orbital theory, the double bond in C2 molecule consists of 2 pi bonds. Yes, this is correct only. Just write sigma 1s, sigma star 2s, sigma star 1s, sigma star, sigma sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Okay. After this, what I told you, we have to write pi 2px equals to pi 2py. Okay. So after that, sigma 2pz. This is what we need to write. Okay. So carbon C2 means how many electrons? Carbon atomic number 12, atomic number 6. C2 molecule means 6 2 is 12. So fill 2 electrons, 2, 2, 2, 8 over 9, 10, 11, 12. So all the, like, see, bonding, anti-bonding cancel, bonding, anti-bonding cancel. So we are remaining only with the pi bonding electron, pi bonding molecular orbital electrons. So how many are there? 4. Bonding electrons are 4, anti-bonding electrons are 0 by 2. So we are having 2. Okay, so 2 we have. So these 2 bond, this, so what is the bond order here we got? So bond order we got is 2, and that bonds are just formed by the pi electrons only. So it is only pi bonded, pi bonds only, not sigma bonds, okay, in C2 molecule. I hope it is clear, right? So whenever we have electrons lesser than 14, we have to follow this order. If more than 14, this order we have to follow. Less than 14 this, more than 14 this, even equals to 14 also this one. Okay, I hope everything is clear. So if you want to learn more about molecular orbital theory, so guys remember, so one is molecular orbital theory, another one is valence shell electron pair repulsion theory. So these two topics from chemical bonding, so no one should skip. Okay, so if you cover these two topics, there will be at least 2 questions in your hand, at least in the minimum. In very bad situation also there will be 2 questions in your hand by these 2 topics. Okay, so try to cover this, and you no need to worry about the topics. So I already covered 2 videos, special video on molecular orbital theory and one special video on valence shell electron pair repulsion theory. Okay, so you can watch them in the playlist chemical bonding by Ajay Sir. You will be getting these videos. Okay, or molecular theory by Ajay Sir, you can type, you will get these videos. Okay, there you can watch. Okay, so statement 1 is false, statement 2 is correct. So which is correct? 4th option. 1 is false, second one is true. Go with option number 4. Okay, let us go one more question here. 1 mole of, okay, the isobar of 1 mole of ideal gas, very interesting here. 1 mole of see again in paper 29th paper also I have seen, April 29th paper, which is, this is 30th paper, in 29th paper also I have seen similar kind of question. Okay, so it means I think examiner is giving same level of questions in all the 3 exams. All these are not easy actually, they are moderate to hard only. Okay, so they are moderate level of exams, or even hard also few questions. Okay, it's not at all easy paper. Okay, with the given time if you consider. Okay, so these similar questions are repeating. Okay, I suggest you people to follow all the PYQ questions, I mean 20-25 papers whatever we discussed till now for AP, and also see for MPC student there is one beneficial thing. What it is, it means, see, first of all they will be finishing the BPC exam, right? So you can collect the questions from your friends, like what kind of questions are asking in the exam, and you can also prepare based on that also. Okay, this is one more thing you can do during your exam time. Okay, so now let us see, isobar of 1 mole of ideal gas was obtained at P atm, okay, at pressure P. The slope of isobar is this much. What is P? Okay, we have PV equals to RT for 1 mole. Okay, from this I am writing P, see P is constant now, so I am writing, because isobar they are saying, isobar means pressure is constant, so V equals to R by P T I can write. Okay, since they are saying about slope, so I am derivating this dV by dt equals to R by P. So what is our slope now? This is our slope, so dV by dt is our slope. Okay, right, this is only slope now. So we are drawing a graph V versus T. Okay, V versus T. So in this, how can we find the graph? I mean, how can we draw the graph? So in mathematics you are learning now, y2 minus y1 by x2 minus x1 is the formula for slope m. So that is what dV means v2 minus v1, dt means t2 minus t1. That is what the slope here, which is equals to R by P. Okay, R by P, which is equals to how much they mentioned here. So 0.82. Okay, 82 liter Kelvin inverse. In this, what they are asking, what is P? Okay, so this is the slope. So from this, R means universal gas constant. So what is the value of R? 0.082 liter atm. Liter atm Kelvin inverse, mole inverse, that thing now. So they just send this side 0.82 liter. Okay, and P this side. Okay, so this is how many times? 1 by 10 times. Okay, so 1 by 10 means it is nothing but 0.1. What is that? It is nothing but 0.1. So what is our P value here? 0.1. So this is our answer. Okay, I hope it is clear and very interesting question it is. Okay, then next. A carbon and hydrocarbon containing carbon and hydrogen has 75% of carbon, 32 grams of this carbon was completely burned in air. What is the weight of CO2 formed? Okay, so for example, any substance, okay, let us change the color. So if any substance containing, for example, I have a hydrocarbon like HX, so complete whatever the carbon present in this compound will be completely converts into CO2 and hydrogen will be converts into water. This basic thing you need to understand here first of all. Okay, now what they are saying, the hydrocarbon contain carbon and hydrogen, 75% of carbon is present. Okay, so in this 32 grams, okay, 75% we can write now. So now this is what weight of carbon I am finding, weight of carbon equals to out of 32 grams of hydrocarbon, 75% is carbon. That's why I have written like this. Okay, now 25 3s are 25 4s are 4 8s are. Okay, so 8 3s are, so 24 grams of carbon we have in the given hydrocarbon. In the given 32 grams of hydrocarbon, how many grams of carbon we have? That is 24 grams, right? Okay, so now listen here carefully. So whenever we have one carbon, upon complete combustion, this will be giving CO2 gas. It means this CO2 gas, for every 1 mole of CO2 is forming. For every 1 mole of carbon, we are getting 1 mole of CO2. It means for every 12 grams of carbon, we are getting 44 grams of CO2, right? It means how much weight they mentioned in the question now, as per the data, this is 24 grams. So for every 24 grams, just multiplied by 2 now. Here also you can multiply by 2. So for every 24 grams, we should get 88 grams of CO2. I hope it is clear. Again listen here, we have 24 grams of carbon from the 32 grams of hydrocarbon. I hope it is clear. This is how we have calculated here. Now whatever the carbon present in the hydrocarbon, that will be completely converting into CO2. If we have 1 mole carbon, we have 1 mole carbon dioxide. If we have 12 grams carbon, that will be converted into 44 grams of CO2. Okay, because molar mass of CO2 is 44. Molar mass of this carbon is 12 grams. Okay, now in the given question we have 24 grams, it means 12 grams 42, 24 grams 88, just multiplied by 2, that's it now. So 88 grams. In the given options, you will not be having 88 as the answer, but you have something like 0.088. See why it is, because they told us to express your answer in kg. We got answer in grams, 88 grams we got. So what is the weight in kg of CO2? So what is the weight in kgs? So 88 grams. So how can I write this 88 grams? So we can write in kgs by dividing with 1000. Okay, so by dividing with 1000 means, so 88 by 1000 in 1000 kgs. So it can be 0.088 kgs. This is the answer. Okay, it is there in the next page. Look here, 0.00, 0.0888. Okay, then next. Again listen here, one more interesting question we have. So guys, so why you are looking silently? Just click on the like button and you can write something in the comment box so that we can discuss about the question in more interactive way. Okay, so here we have H2O2. Okay, so this H2O2 undergoing atomization, forming 2 atoms hydrogen, 2 atoms of oxygen. Okay, so for this atomization process, this is the energy released. Okay, now if atomization of OH, like bond dissociation energy of OH is given is this much, then they are asking for OO. So just simple one. So what is, this is the process now. So what is that process? Atomization of H2O2. How much energy is this much energy, which is coming from H2O2. In H2O2, what are the types of bonds we have? This is the structure of H2O2, right? So how many OH bonds we have? 2 OH bonds. I am writing 2 OH, okay, plus, okay. And next, how many OO bonds are there? 1 OO bond I am writing, okay. You can write like this. So what is this value mentioned here? 1066, okay, which is equals to 2 into, what is the value of OH here? It is 464, you can write here, and 1 OO bond they mentioned, okay. So from this, what is the value we are getting here? So it is 82189, okay. This one OO bond, okay. So this is 066, okay. So from this, so if you subtract this 928 from this, you will be getting 138, okay. So 138 is the answer for OO, okay. This is the energy required, okay. So then OO bond dissociation energy will be this much. So we have answer as 138. I hope this is very clear without any confusions, right? 1066 minus 928 is 138. That is what our final answer here, okay. Then next, again one more interesting question we have. At 27 degrees Celsius, the Ka, acid dissociation constant of acetic acid is this much. What is the percentage of ionization? So from Ostwald dilution principle, the degree of dissociation alpha is equals to what? Root over Ka by C, okay. This is a formula we can use here, okay. So alpha equals to, what is the value here? They given 1.8. I am writing 18 into 10 power 6 minus 6 by C value is 2 into 10 power minus 2 I am writing, okay. There is no issues now, okay. Just remove this minus 2 and this is minus 6, I can write 10 power minus 4, okay. So 18 is there, 2 9s are. So I can write root 9 means 3, 10 power minus 4 is there, and root means 1 by 2, so I can write 10 power minus 2, okay. So this is what the alpha value here we got, okay. So they are asking about what is the percentage. So percent means 3%, okay. So this I can write like this. So this is 3, so 3%, okay. That is our answer here. I hope it is also clear, right? Next, so here we got now 3, that is what our answer. So let's move further. Observe the following unbalanced equation, okay. Identify the correct statements, okay. Let us understand this. H2O plus sodium. So what we can get here? NaOH plus H2 gas is released, okay. In the next one, it will be forming HF plus O2, okay. This is a product, okay. Now let us understand what are the statements they have given. Let us see. In one, water is getting oxidized. Is it water is getting oxidized or not? Let us check. So oxygen minus 2, here also minus 2, hydrogen is, okay, no, oxygen is not getting oxidized, water is not getting oxidized, water is getting reduced, and sodium is getting oxidized. Here it is 0 now, sodium in atomic form, here it is in 0 oxidation state, here in +1. So if this species is getting oxidized, sodium is getting oxidized and water is getting reduced. In the first process, water is getting reduced. So in both 1 and 2, water is getting reduced. In the first one, it is getting reduced. In the second one, see, atom F, fluorine is 0 oxidation state in molecular form. So here it is -1. So it means what happening here? So here it is, here fluorine 0 to -1, it is undergoing reduction. It means water is undergoing oxidation. Here oxygen -2, here it is 0 oxidation state. So this process is what? Oxidation, okay. So second reaction is, in second reaction water undergoing oxidation, in first reaction water undergoing reduction. So RO, reduction, oxidation, in one reduction, in two oxidation. Let us verify our options. In one water is undergoing reduction, yes, in H2 and in 2 undergoing oxidized to O2, yes, correct. So option 4 which is mentioned here is correct, okay. Hope it is clear, nothing is confusing. Ions of an element X required for interneural transmission. The ions of an element Y helps in the transport of sugar into cells. X and Y are okay. From the options you can go with calcium and sodium as per the given data, because these are static questions, I mean directly. The alloy lithium and magnesium, that is magnesium used to make armor plates. So what is that? Lithium and magnesium. So directly you can take option number 3. Acid X is prepared by acidifying aqueous solution of borax. So borax upon oxidation, upon treating with aqueous solution in acidic medium, so gives H3BO3, orthoboric acid. See, this orthoboric acid is a Lewis acid, okay, and it is it can accept a pair of electrons, therefore I am saying Lewis acid. Now it is having white liquid, not liquid, it is solid, okay, with soapy touch, okay. So this is solid actually, but they mentioned it is liquid. It is a white solid with soapy touch, but here mentioned a liquid. So option 1 is incorrect, okay. It is a sparingly soluble in water. Yes, it is sparingly soluble. It is not a strong monobasic, okay, it is a weak acid actually, and it is a Lewis acid. I told you now, it will be having one empty orbital, to that it will be accepting a pair of electron, therefore Lewis acid it is. So fourth statement is correct, second statement is correct. So 2 and 4 is correct, first option is right, okay. Then next, here do we have any question is missed? Yes, okay, 2 questions are there. Among the following the neutral oxide is, yes, see, whatever the book you can take, whether NCERT or any study material you can take. So if you look into the oxides of main block, okay, P block, so there will be list of oxides. So just look into the oxide list, which one is acid, which acidic, which one is basic, which one is amphoteric, and which one is neutral. So if from that you can expect one question, okay. So nature of oxides, you can look into this, okay, nature of oxides, which is important thing to study. So here neutral oxide is only CO, and these are acidic oxides. What is this? These are acidic oxide, remaining are acidic, okay. Hope it is clear. Identify the correct statement about photochemical smog. Okay, photochemical smog, it is also called as oxidizing smog, okay. It is correct, forms cracks in rubber, and PN is one of the component of photochemical smog, okay. Then look here, so first option which is having all 3 are correct, yes. Next, aniline and water aniline can be separated from mixture of chloroform and aniline by a technique. What is the technique? Distillation is a technique. And the next, from aniline water mixture by technique Y, X and Y are. So aniline can be separated from aniline water mixture by what? Steam distillation, because aniline can be separated in the steam form now, so it can be steam volatile, I can say, okay. So in this case it is steam volatile, so steam distillation, here it is normal distillation. So distillation and steam distillation we have options, okay. You can go with this. So where do you get this? So you can study this in the 11th class, purification techniques, organic, okay. So after completing your GOC, there will be purification of organic techniques, okay. So you can go through that, very very important, so you can learn from that, okay. Or if you want, you can write in the comment box, so that I will be covering for you, okay. But somehow you need to learn this, okay. So acidic nature of alkynes here. So they have given 3 alkynes, they are asking about the acidic nature. So always remember, electron withdrawing group containing alkynes are more acidic, and here acetylene is there, methyl acetylene. Electron withdrawing group, if it is present, that is more acidic. We know alkyl group as electron releasing group. Here we have ethyl group, here it is methyl, here it is ethyl. So this is stronger electron releasing group than this. Therefore, this is having less acidic nature than this. So 2 is more acidic, and here dimethyl. So why they show acidic nature? Because of this acidic hydrogen. This sp, on sp carbon we have one hydrogen, na? Those are acidic hydrogen. These are acidic hydrogens. Okay, due to that reason they will be showing acidic nature. So after removing that, the negative charge can be stabilized by this pi bonds, I mean sp hybridized electronegative carbon. But when it comes to acetylene, in the third case dimethyl, this side methyl, this side methyl. See, in this case and this case we have acidic hydrogen, but here there is no acidic hydrogen. Therefore, this is not acidic. Okay, so it means this is least acidic. So 2 is more, the next 1 and the next 3. So 2 is more maximum, next 1, next 3. So option number 3 is correct. Okay, I hope it is clear without any confusions. Let's move further. To this alkene, we need to add water in acidic medium. So whenever we are adding water in acidic medium, first add H plus as electrophile. So now adding hydrogen here will be creating a positive charge on this carbon, which is secondary carbocation, more stable than the primary one, right? So that's why we need to add hydrogen on this primary carbon and create a more stable secondary carbon at the center. Okay, now here you can add water, H2O. This is a nucleophile, attacks here and forms water, OH, like this, and forms alcohol like this. So this is our product, this C3H8 is, H8O is this one. Okay, now this upon treating with some X giving Y. Okay, so this Y upon treating with benzene and AlCl3. So this is nothing but, see, look at here, this is something looking like benzene with AlCl3, anhydrous AlCl3, and if we have one alkyl chloride, that will be giving Friedel-Crafts alkylation. Okay, what is that? Friedel-Crafts alkylation. So in order to convert that, we need to remove this water OH from here and replace it with some chlorine. So what is that? What is a suitable reagent here? So we can treat that with anhydrous, I mean we need to remove this now. So you can use concentrated HCl and ZnCl2, anhydrous ZnCl2. So this is a Lucas reagent. What is that? Lucas reagent converts this secondary alcohol to chlorine. Okay, remove this OH using this H plus, and that Cl minus will attacks here and forms this alkyl chloride. Okay, so this is our Y, this is our X. Okay, I hope it is clear up to here. Now this will be reacting with benzene. Okay, so in presence of AlCl3 anhydrous, so remove this chlorine from here using this AlCl3, remove this. So this is the carbocation we are getting here. This will goes here, positive charge generated on secondary carbon, and this is the nucleophile and carbocation is electrophile and will be giving us cumene as a product. So Z is our cumene, this is our product. Now let us check the options. See, in option C we have X is Lucas reagent, Y is, this is the intermediate we got, yes, and Z is cumene we got here. Isopropyl benzene, you can also say it as this structure, you can call it as isopropyl benzene. Okay, so now I will be telling you one more thing. The cumene upon treating with oxygen, okay, so these will be forming phenol plus acetone. So this is what? Preparation of phenol from cumene. Okay, this is one of the important reaction, that's why I added here. So Z, they will be adding O2 upon heating, gives some P. What is our P? They may be asking, that is phenol here. I just added one more point to that. Okay, then next 141 here we have. Observe the following. Okay, the number of diamagnetic and paramagnetic species is respectively. Okay, if you observe this, so let us discuss about paramagnetic and diamagnetic species first. Okay, paramagnetic means they should contain some unpaired electrons, at least one unpaired electron. Diamagnetic means no unpaired electrons. We know according to the molecular orbital theory, oxygen O2 molecule will be having two unpaired electrons now. You can write that orbital sigma 1 star 1s, sigma star, sigma 1s, sigma star 1s, like that we will be writing now. So as per that it will be having two unpaired electrons. Benzene is having no unpaired electrons, so I can say this is diamagnetic. Okay, Cu plus 2 having D9 configuration. So D9 configuration means at least one unpaired electron will be there now. So one unpaired electron, paramagnetic. So Cu plus D10 it is no unpaired electron. So benzene, Cu plus is diamagnetic, and here manganese plus 2, here iron plus 3 and plus 2. Okay, okay. Now these are not para, not dia, but they have some ferrimagnetism. So that is not the case. They are asking only para and dia. So we need to look only about para dia. Here NaCl is there, Na plus Cl minus. So both are electronic configuration. If you write for sodium, it is like neon gas configuration, inert gas configuration. For chlorine also, chloride ion also inert gas configuration, no unpaired electrons. So this is diamagnetic. And O2 plus O2 2 unpaired electrons, O2 plus 1 unpaired electron. So paramagnetic here. So NaCl is one paramagnetic, Cu plus another paramagnetic, NaCl one diamagnetic, Cu plus another diamagnetic, and the next C6H6 another diamagnetic. So these are the three diamagnetic species, and other this O2, Cu plus 2 and this O plus 2 are diamagnetic, paramagnetic. So 3 dia, 3 para from the given options. Okay, so these are not the one. Okay, so those are having ferromagnetism, antiferro, that is ferrimagnetism. You can check for that. Okay, that's why 3,3 is correct here. The next here we have 200 ml of 30% weight by volume of volume by volume of a solution is mixed with 500 ml of 40% volume by volume of other solution. First of all, let us understand this. See, this kind of questions are definitely a time killing questions in the exam. Within 1 minute, it is really little difficult to solve. Okay, let us try once. Okay, volume by volume means 30% volume by volume means 30 grams of this solution contain 30 grams. See, 100 ml of this solution contains 30. See, listen here carefully. Whenever it is mentioned as 30% or some X percent volume by volume, it means in every 100 ml of solution, take any 100 ml of solution, in that 30 ml of solute will be present. I hope it is clear. For every 100 ml of solution, okay, how much ml of this solute will be present? 30 ml of solute will be present. For example, you can take one whiskey bottle. So on that whiskey bottle, it will be generally it will be mentioned as 35% alcohol content. Volume by volume percentage it might be mentioned. So what does it mean? So in in every 100 ml of that whiskey solution, if you take, okay, it contains 35% pure alcohol. I hope it is clear, because alcohol is the solute in that case. So now here 30% volume by volume means for every 100 ml of solution, 30 ml will be solute. I hope it is clear. Now what is the volume of solvent? 100 minus 30, 70 ml will be solvent. I hope everything is clear. Now let us look into the question properly. Okay, so now this is taken how much ml? 200 ml. For 100 ml, 30 ml of solute will be there. So for 200 ml solution, how much it is? 60 ml solution, 60 ml of solute will be there. I hope up to here it is clear now. Keep it aside. Next, with 500 ml, so for again for 500 ml, 40% volume by volume of another solution. It means for every 100 ml, there will be 40 ml of solute. Okay, so for every 100, 40. For every 500, so for every 500, 40 into 5, 200 ml. 200 ml of solute will be there. So what is the total ml of solute? So it will be how much? 260 ml of solute will be there. So what is the total volume of solvent? This is 200 ml, this is 500 ml. Total upon mixing gives 700 ml of solution, right? I hope it is clear now. So now upon mixing these two, what is the volume by volume percentage they are asking? What is the volume percentage of resultant solution? Hope it is clear now. So by mixing this solution, we will be having this, the solute concentration is this much, 260 ml of solute we have, and total solution is 700. So it means, well, volume by volume if they ask, you have to take volume of solute, how much? 260, okay, and volume of solution in the denominator, total volume of solution is 700 into 100, this is a percentage calculation. Okay, so now by doing this, so 2 zeros, from this we will be getting, so 3s are 21, okay, so the next 21 means 5 we have, so it means 7s are, okay, around 37%. So we have option number 4 which is correct here. Hope it is clear without any confusion. Okay. So then next we have 143 question here. Let us discuss about this. The equilibrium constant for the reaction given like this. This is the equilibrium constant. So K equilibrium is 10 power 15. What is the delta G? Gives free energy. So we have delta G naught equals to minus RT ln K equilibrium. This is a formula we have. Okay. So now in the data they have mentioned RT by F into 2.303 is this much. Okay. So I am taking that minus RT. See ln I am writing RT into 2.303 log ln I can write like this. Ln can be written as 2.303 log K equilibrium value is 10 power 15. I am writing that. Okay. This is what I have written. See, they haven't given RT value. This is the actual formula. They have given the value of RT by F. It means I should divide this equation with F and I can multiply with F. Therefore F cancel. So there is no nothing wrong in that doing like this, right? So now minus RT by F into 2.303. How much value it is? So they mention it as minus 0.06. So RT into 2.303 by F. How much we are getting? They mention it as 0.06. I am writing as it is. Okay. Into log into 10 power. See, whenever we have log A power B, something like this, if we have, you can write it as B log A. Okay, B log A. This is the logarithmic formulas. Okay. So it means 10 power 15 I have means, can I write 15 log 10? So log 10 will be 1. Okay. Into F. I am writing F here. That's it. Okay. I hope it is clear up to here. Now I am erasing this. Okay. So here F value also they mentioned 96500. So minus 0.6 into 10 power minus 2 into 15 into log 10 means 1 into F means 96500. Okay, this 00, this is cancelled. Okay, by simplifying this minus 90 into 965. So after doing this you will be getting around 86 minus 86 850 you will be getting in joules, but they are asking us answer in kilojoules. Okay, so kilojoules means divide by 1000, so that if we are dividing by 1000 it will become minus 86.85 kilojoules you can write. So kilojoules we got. So what is our answer here? Minus 86.85 is the answer for this question. I hope it is clear, no confusion, right? So you can, yes, anyone in online please? Let us move further. 144 here. For a first order reaction, a plot of R log, okay, and X taken straight line passing through the slope of, okay. So simple here. So what is the first order rate equation we have? K equals to 1 by T ln initial concentration of reactant by reactant concentration at a time t, like this we should write. Okay. So they have drawn a graph ln R naught versus R naught by R versus time. Okay, this should be on y and this should be on x. So I am writing here ln R naught by R at time t, which is equals to K1T. So how it is looking? So this is y. So this is y equals to mx graph. Okay. So y this is should be on y axis. So I can take here on y axis ln R naught by R t, on x here it is t. So here K1 is m. So it means you will be getting a straight line like this, right? So what is our m here? So our slope is K1. Okay. So a straight line with a slope of straight line x, the rate constant of this reaction is, so that is x only na, so K1 which is equals to slope, that is x. So that is our answer itself. So let us see the options what we have. Yes, so in the options we have x. See, just a formula, using formula how can we draw the graph, that is what they are expecting from us. So from that we got x as the answer in the slope. Here you can look. So from this graph we got slope as x, this is K1, as per them the slope will be whatever we got, m is our slope, that is what K1, K1 equals to x, that is x is the answer, right? Okay, then next, okay, let us solve this question. So red phosphorus when heated in a sealed vessel at 800 Kelvin gives x, white phosphorus when heated in under high pressure at 473 Kelvin gives y, okay, and x and y are, see, both red phosphorus, white phosphorus upon heating at this respective temperature both provides black phosphorus only. So one is alpha black phosphorus, another one is beta black phosphorus, that is what the answer. So for this you can go through p black phosphorus, I mean 15th group, okay, there it will be mentioned, okay. Oxo acids of phosphorus formed in the following reactions, okay, the acid formed in which of the following reaction does not contain pp bond, okay, it does not contain pp bond, okay, does not contain pp bond means, see, white phosphorus is more reactive than red phosphorus, remember this, white phosphorus is more reactive than red phosphorus. I can say this is more stable, therefore less reactive. Red phosphorus is more stable than white phosphorus, therefore red phosphorus is more stable, less reactive. What is that? Red phosphorus more stable, less reactive, I am saying, okay, more stable, less reactive, you can write this, okay, and this is more reactive, it means relatively less stable than the red phosphorus. White phosphorus is relatively less stable than the red phosphorus, you can understand this, okay. Now whenever we are heating this in alkali medium, whenever we are treating that in the alkali medium, it gives phosphine gas and also NaH2PO2, so this is formed here, okay, in this medium, okay, but I told you this is more stable, low reactive or less reactive, so it cannot be affected much by alkali medium, okay. It means what I am saying, it does not contain, okay, does contain. So red phosphorus will be containing that pp bond, in P4 it will be like this actually, so P4 will be like this, okay, they contain this pp bonds. So in red phosphorus it will be stays as it is, but white phosphorus will be like, see, it is undergoing reaction and forming some compounds which are having no pp bond, okay. So you can say that pp bond is not present in white phosphorus upon treating in alkali medium, but red phosphorus will contain that pp bond because it won't react with the alkali medium, it will not be much affected by alkali medium, okay. Next, SbCl3 is more covalent, which of the following is not correct, okay. See, here SbCl3 is there, so I think you know Fazan's rules. What are these Fazan's rule? So it explains the covalent nature in ionic compounds. See here, cation with more positive charge, anion with more negative charge will results to form more covalent character. Cation should have more positive charge, anion should contain more negative charge. The resultant compound will be more covalent. Here cation is having +3 oxidation state, anion is having -1. Here anions are chloride -1, cation is +5. Now tell me, cation with more positive charge, anions are same here. So cation is having more positive here, therefore this compound is more covalent, but they given in the reverse order. SbCl3 is more covalent, they are saying. No, SbCl5 is more covalent, right? So option 1 is not correct one. They are also asking for not correct. You can choose first option, okay. So I2O7, yes, this will be decomposes because that is not stable here, that is correct only. So this is a powerful oxidizing agent, okay. So which is incorrect one, first option is incorrect here, okay. Then next, in acidic medium, which of the following change is not correct about oxidizing power of KMnO4 in acidic medium? So KMnO4 in acidic medium, always remember in acidic medium here KMnO4 is having +7 oxidation state, +7. So whenever it is involving acidic medium reactions, redox reaction, oxidation reduction reactions, it will be converts into Mn+2. This is the standard way you can remember. So what is the conversion? So it will be converts into Mn+7 converts into Mn+2. Which are the following change is not correct about oxidizing property of KMnO4? See, this is the correct property of KMnO4, but here they mentioned, see Mn+2 is converting into MnO2. That is not possible now, because already KMnO4 in Mn manganese in +7 oxidation state, but here they mention it is +2, which is not correct, right? Yes or no? See, which of the following is not correct about oxidizing property of KMnO4? So the reverse, like it is +7 actually in this KMnO4, they mention it is +2, which is not true. So you can choose this, because they are also asking not correct statement, right? Okay. So it can oxidize, KMnO4 oxidizes sulfide ions to sulfur and sulfate, oxalic group to carbon dioxide gas. Yes or no? Yes. So these are possible, but second option is incorrect. Why second option? What is the correct option then? I mean correct statement for this, it should be like this: Mn+7 converts into Mn+2. This should be the proper statement they should give there, but they have given in some other way that Mn+2 is converting into MnO4, that is MnO2, it means +4. So that is not the correct one, right? Because there is no Mn+2 oxidation state only, there is +7 oxidation state, so that is incorrect one. Hope it is clear. Next, again, so again, if you are really preparing for your EAPCET or whatever the competitive exams for +2 standard, so you should not skip coordination chemistry at any cost, and from that also you should not skip Werner's theory, the next valency bond electron VBT, valency bond theory, and crystal field theory. These three things you should not skip at any cost. Okay. Now from this, from crystal field theory, we have ligand field strength. What is that? Ligand field strength. So from that we have a experimental order of these ligands, which is strong field ligand, which is weak field ligand, based on the strength. So field strength, increasing order of field strength we need to arrange. So from that we have a question here. So which is having maximum field strength here? So NCS minus is having, out of the 4 options, out of this NCS is having more splitting ability. Then next, after this H2O is having more, okay, H2O, what is the option for H2O? A, okay. After this OH minus, okay, arrange the given, okay, OH minus, which is having option C. So B, A, C, and least is D. So we have option 2 here. Hope it is clear. So this is nothing to worry about this. So just go through coordination complexes either from your textbooks or from materials or from see, I think I also covered on the CFT class also I have covered, I think so, VBT I have covered. So one shot on coordination chemistry. So you can search in our playlist, that video might be useful for you in order to cover this coordination chemistry. I have covered the chapter using previous year questions of NEET and EAPCET only. So you can go through that, okay, that might be useful. Okay, so you can search about this order properly in any of your textbook or in the Google or in any of the materials, okay. The next statement 1, 2 we have. So natural rubber is a polymer of 2-chloro-1,3,3 butadiene. No, this is 2, this is not 2-chloro, this 2-chloro one is the like 2-chloro, this is neoprene and chloroprene. So this is chloroprene, it is a monomer of neoprene, okay. So this is not for natural rubber. So for natural rubber here, it's a polymer. So no, this is not the natural rubber polymer, monomer of natural rubber. Natural rubber is a polymer of, no, this is not. See, from 2-chloro-1,3 butadiene, we will be getting neoprene. So that is what? That is what? Synthetic rubber. but here they are saying natural rubber. No, this statement is incorrect. Okay, next one, 1, 3 butadiene styrene copolymer is synthetic rubber. Yes, that is correct only. Statement 2 is correct. So let me check the options. Statement 1 is incorrect. Statement 1 is incorrect. Statement 2 is but statement 2 is correct. Yes, second one is synthetic rubber. First one is not the they mentioned it as natural rubber, but that is not true. Okay, so 1 is incorrect, 2 is correct. So fourth option is correct. Okay, next again biomolecules. Just go through the list of some basic carbohydrates, aldose, ketose, monosaccharides, disaccharides. Therefore it will be giving you some clarity, and which is reducing sugar, which is not reducing sugar, and what are the basic tests given by aldose sugar, ketose sugar, how can we differentiate them. So these basic things you have to look into it, okay, from biomolecules. Okay, so sucrose contains what? Sucrose contains which of the following saccharides contain alpha D glucose, beta D glucose units. So which of the following contains beta D glucose? See, sucrose contains glucose plus fructose, okay, and this glucose is alpha D glucose, beta D fructose. Okay, so what is the combination? We have alpha D glucose, beta D fructose. Sucrose is a combination of alpha D glucose, beta D fructose. It is having 1, 2 glycosidic, alpha beta glycosidic linkage, and it is a non-reducing sugar. Okay, you can write that. Very, very important points these are. And what about lactose? Lactose is having galactose plus glucose. Okay, what is that? Galactose plus glucose. Both are beta D galactose, and the next here also beta D glucose. So second option is correct, because in this lactose we have beta D glucose as a unit. So this is correct only. Next, what about cellulose? Cellulose will be having what? 2 units of beta D glucose. What it is having? 2 units of beta D glucose. It is having 2 units of beta D glucose. So 2, 3 are correct. So 2, 3 are correct here. Okay, so I hope it is clear. So starch, the unit of starch only is amylose, which is again like glucose polymer only, but it is not the correct one here. So what is the correct one? Galactose plus cellulose. This is correct here. 2, 3, right? So I hope you know that glucose contains alpha D form, alpha form, beta form, furanose, pyranose forms. All these things I think you know about that. If you don't know, just go through this, which is mean by what is mean by beta form, what is mean by alpha form, because glucose having some open chain structure and also closed chain structure. So whenever it is in closed chain, we will be looking about this alpha, beta forms of glucose. Okay, can go through that. Okay. Observe the following reaction. Which of the statement is not correct regarding X? Okay, so to this, see here we have phenyl ring C6H5 with a bulky alkyl group this side. Okay, so now, so that we are adding sulfuric acid here we are doing sulfonation. Okay, so on this benzene ring, let us say that bulky group I am taking it as R just to represent this complete chain as R. So here the reaction takes place and forms sulfonic acid. Okay, so this upon treating with NaOH forms R SO3 minus Na plus. So this is a salt we have. So this is a chain we have. So let us check the options. So X. Okay, this is what we got. So what they are asking? Which of the following is not correct? Yes, that is what I am checking. So which of the following is not correct? See, sulfate we have SO3 minus we have SO3 minus Na plus we have, right? So what is the anionic part? We have sulfite, SO3 sulfate ion we have. Okay, so if it is sulfate ion, check, negative charge is there, so it is anionic detergent. So anionic, okay, and they are asking about not correct one. So they are saying here it is cationic. No, it's not cationic, it is anionic. So this is the incorrect statement you can directly choose for. Okay, I hope it is clear, because SO3 minus is the unit we have from this part to this our alkyl group chain. This is what the chain which is showing the this detergent properties. Okay, for that we have sulfate like SO3 minus charge here. Okay, that is anionic detergent, not the cationic form. Okay, but they are saying it is a cationic form. So this is incorrect. You need to choose that incorrect statement only. So third option is most appropriate answer for this. Okay, the next one we have the next page. Okay, an alcohol X is converted to corresponding chloride Y by shaking it with concentrated HCl at room temperature, and reaction of Y with magnesium in dry ether and then with water gives Z. What is YZ here? Very easy question, looking lengthy, right? But really easy if you are, see, to be frank, in order to solve this question you need to have some clarity on your organic chemical reactions. If you really going just to direct to the exam hall, you cannot do these questions, okay, because they require at least some basic understanding of organic reactions. See, an alcohol X is there, X contain 5 carbons, okay, it means something like pentane, something like that, okay, C5H12, it means what is the degree of unsaturation? 0, okay. How can we find degree of unsaturation? Just compare the given hydrocarbon chain with respect to alkane. So with 5 carbons, what is alkane? The general formula of alkane is CnH2n, H2n plus 2, C5H10 plus 2, 12, H12, yes, this is C5H12 only now. So it means it is an alkane. So it's a alkane. So with 5 carbons, let us say 5 carbons are there in this, wait for some time, is converted into a corresponding chloride by shaking with the HCl. So now you need to know that nucleophilic substitution reactions here. So since they are saying just by shaking with a concentrated HCl it is converting into chloride, it means that alcohol group is reacted with H plus ion and water elimination takes place, and to that position, that OH position, new nucleophile Cl minus is coming. It means that must be tertiary alcohol. So I am writing like this, tertiary alcohol for our understanding. Okay. Now whenever we treat this with concentrated HCl just by shaking, so remove this OH and this H plus, okay, and remaining part you can write, okay, this is a carbocation which is tertiary, on that this Cl minus will attacks by SN1 mechanism, okay. So like this, so finally this will be our answer, okay. I mean this is a chloride Y, this is our Y, okay. Look here, option 2 and option 1 contains this chloride, right, we are almost near to the answer. So now we can treat this with magnesium, okay. If we treat this magnesium chloride will be forming Grignard reagent, so I will be writing with violet color only, MgCl, like this. Now this carbon part, this chain will be having negative charge, this compound will be having positive charge, okay. So if we are adding water, hydrolysis, in water we know one H plus ion and OH minus ion we have, which is a weak electrolyte. So the negative part of this carbon chain will be taking this positive H plus ion and forming a hydrocarbon chain like this, alkane like this, okay. So this is our product, okay. So see this kind of alkane, yes, here we have, and this is the chlorine, yes. So option 2 is correct. To be frank, this is little time taking question only, you need to think, because in the exam you will be in the rush, so getting all these things are really takes some time, so it requires a lot of practice from your side, so then you can solve this kind of questions, okay. So anyways, you can just go through this kind of questions once again. After watching this, you can solve same question one more time just by looking into the question itself, okay. So any time, like if you are not fully prepared, so and you are listening to some class, and if you are feeling that class is very important, so after listening to the class, after making the notes, just have a quick look into that notes and take all the important questions from that in a paper and just try to answer them. Same questions you take as in a paper, in a white paper, and give a try on your own without looking into the book again, okay. Now you will be getting the clarity whether how much extent you have clear with those concepts which are discussed in the class. Okay, so this is how you can maintain clarity, and this is how you can get improvement in the short term. Okay, I hope you got what I am saying here. Then next, alcohol here, this is alcohol, again same alcohol undergoes dehydration when passed through copper, okay, and forms X can be prepared, okay, forms copper, okay, X can be prepared from which of the following? See, same molecular formula we have seen above also, it means 5-membered compound with alcoholic group, okay. So treated with this one, okay, let us see, okay. So X can be prepared from which one? See here, we have carbonyl group, acetone, we are treating with the ethyl group. So we required 5 carbons and 1 OH group. So 1, 2, 3, 4, 5, 5 carbons we are having 1 OH group. So this is might be possible. See, formaldehyde we have and this one we have. So 1, 2, 3, 4, 5 we can get, but you know that cannot be treated with copper. So passed through the copper means, see, this is what we required. So this is what the alcohol we required. So why we require this alcohol only? Because when we treat with copper at 573 Kelvin, we will be getting a product. See, this CH3 is there now. So from that dehydration takes place, H and OH will remove and we will be getting an alkene like this. Okay. So this happens only with the tertiary alcohols, but not with the primary and secondary alcohols when we treated with copper. Okay. This is the like process you can remember. Only tertiary alcohols when treated with copper in 570 degree Kelvin Kelvin temperature will be giving alkene, okay, by removal of OH and H. Okay. So this is not possible in this case and not here and here. So first one is the most appropriate answer. Next, alkene X, okay, alkene react with X to give, okay, reacts with Y to give Z, Z forms, okay. Okay, so this is the formula of alkene, C3H6, it means an alkene, okay. So let us say this is our alkene, okay, react with X, okay, gives C3H8O, it means alcohol is formed, okay. So which reacts with Y to give Z, okay. So let us say here I am writing C3H8O only, H8O, so which react with Y to give Z. Okay, I am writing as it is. Let us construct that properly. And Y forms 2,4 dinitrophenyl hydrazone. So when it is treated with phenyl hydrazine, okay, so it will be forming hydrazone. Yes, it means this must be ketone or aldehyde. Okay, remember that. And it gives yellow precipitate with NaOH. So this Z also gives yellow precipitate with NaOH plus I2. So this is what haloform test, iodoform test. Okay, so which will give that? So carbonyl group, if this is the carbonyl group, it must contain one methyl group like this. Then only it will be giving haloform test. Okay, so in order to make this methyl group, so definitely what our X should be? So X should be added. Therefore we will be getting an alcohol. That alcohol must be present here. Therefore upon oxidation we will be getting a ketone, otherwise it will be giving ethyl like propanaldehyde, which is not the proper one. Propanal, here it should not be aldehyde, it should be ketone. Why it should be not propanaldehyde? See, by adding water, so we can get 2 types of products here. Listen here again. So we can get alcohol like this, by adding H plus here and OH here we can get like this, and by adding H here and OH here we can get like this. Okay, these are the 2 possibilities. So this is our alcohols, this one. So these are the 2 things, any of these can be this alcohol. Okay, let us see what exactly it is. Okay, so now which reacts with Y to give Z. Okay, it means some oxidizing agent here we need to take, some oxidizing agent I am taking. Okay, so if that oxidizing agent is taken here, so this will be giving us ketone. Secondary alcohols gives always ketone, which are having methyl groups, because this Z must contain methyl group, carbonyl group must contain methyl group. Okay, and if I this is a primary alcohol, upon oxidation gives carboxylic acids. So this carboxylic acid won't show this haloform test, only ketones will show haloform test. So it means here it should be, must be acetone only. So our what is our Z here? Acetone. Okay. So now what is our, why we need to check? What is our what is X and Y now? Okay. So what is our X and Y we need to check? Y is oxidizing agent and X is something that should produce water and alcohol, that should be like this. From the 4 options, this won't be, because this follows anti-Markovnikov rule, addition BH3 and gives alcohol like this. But we should not want in this manner, we need in this manner. So here we can take H plus water, acidic medium, addition of water in acidic medium. This is the one case, this is our X can be, but I need to check the options, then only we can say that. Okay, H plus H2, yes, and in the second case chromic oxide, some oxidizing agents like this, CrO3 we can use here. So this is correct only. Okay, so option 3 is correct. Hope it is clear. Let's move further. Phenol with SOCl2. So actually general alcohol, aliphatic alcohols, whenever we are treating with SOCl2 gives RCl, alkyl chlorides, plus SO2 and HCl is released, gas is released. So this is possible only if it is aliphatic alcohols. This is aromatic ring is attached with the OH group. So this lone pair electrons will involve in the conjugation and make the bond strength, stronger bond it will be making, and this OH cannot comes out from here, therefore no reaction is possible here. So this reaction is not possible, okay, because oxygen, between oxygen carbon partial double bond character will be there due to the relocalization of non-bonding electrons of oxygen with the ring pi electrons, okay. So this is not possible. In this case, yes, this reaction is possible but not at this temperature. This is just 273 means 300 minus 273 means around 27 degrees only they are mentioned, but this reaction required at least some 100 degrees Celsius. Exactly if I speak, so it requires 140 to 170 degrees Celsius for conversion of this process, but they mention lower temperature, so I am removing this option. So both are not possible, okay. So both reaction 1 and 2 are not feasible. I hope it is clear. The first case I told you, this is very stable compound, OH cannot comes out, it cannot be substituted by Cl in this process, so reaction is not possible. Second case, yes, reaction is possible but it requires some more higher temperature. So that is it, like at least from 140 to 170 degrees Celsius is required, but they mentioned here 300 degrees Celsius. That is also incorrect. This is the effect of temperature question. Okay, I hope it is clear. If you want, you can exactly find the value from NCERT book or your Telugu Academy book. You can get the exact value here. So both are not possible. So option number 2. Then next, what we have? So one question here we missed, I think so. Let us look into it. Yes. Which are the following set of reagents are required for conversion of ethyl bromide to propanoic acid? So how can we convert ethyl bromide to propanoic acid? 1, 2, 3 OH. This is a propanoic acid. Okay, ethyl bromide we have. So in this, 2 carbons are there. Here we have 3 carbons. It means first of all we need to add 1 carbon more. So for that, here I can use this. Okay. So Cn is there now. So Et C double so C triple bond N. So now 3 carbon it is becoming. Now upon hydrolysis, complete hydrolysis in acidic medium, heating gives carboxylic acid. This is correct. Okay. Now this one, upon treating with magnesium, it will form methyl magnesium bromide Grignard reagent. Okay. Okay. Now CO2 is there now. So on this, I told you magnesium will be positive, ethyl group will be negative. So this group will come and attack over here and forms ethyl COO minus. So how many carbons? 2, 3. Like propanoic acid only now. So this is also correct. Okay, 2 and 3 are correct. So 2 and 3 only. So that is what our answer. Okay. Next. What are X and Y in the following reactions? Okay. So we have benzene diazonium chloride. You can write like this, NN plus Cl minus. Okay. Upon treating with water at 290, okay, 283 Kelvin. Okay. So it will be giving phenol. Okay. So this phenol with again benzene diazonium chloride. Okay. So in the basic medium, so this gives azo coupling product like this. This nitrogen is there now, so it will goes this side, okay, it will comes this side, and this nitrogen, the para position of this phenol will be attached, okay. If this is a phenol, here nitrogen, double bond nitrogen, here this side we will be having, that's it, this is our product. So where do we have this kind of options? See, OH, fine, phenol is formed. So this phenol at para position, it activates the ring, so therefore that will be act as nucleophile, and this nitrogen it will be attacking and forming a compound like this. That is what we have written here. So fourth option is correct. I hope all the questions are done very well without any confusion. So everything is clear now, right now. So if you have any confusions or anything to be discussed, you can write in the comment box. We will be discussing about them separately, and if you want any specific topic to be discussed, you can write in the comment box. We will be discussing that also, okay. So thanks for watching and stay tuned with us. Thank you.